Okay, question number 5. The coil in the DC motor shown in question 3 has a length of L equal to times 10 power L equal to 7.7 times 10 power negative 2 meter, which is about 7 cm, and with 3 times 10 power negative 2, which is 3 cm. So there are 25 turns on the coil, and it's placed in a uniform magnetic field of 0.19 Tesla. So the coil carries a current of 2.8 ampere. So the coil is free to rotate about an axis midway between PQ and RS. Okay. So calculate the force on the longer side of a coil. Okay. So the longer side of the coil is actually where it's at PQ and RS, which is the longest one. Okay. So I just refresh you all, which is this. So it's PQRS. So longer size will be at this part and this part. Okay. So the force at the longer size, which the force will be IL. Now, don't forget the n. Okay. So now because they are giving you how many turns of it, so you need to add up each turns. So it's 25 turns, means I have to times 25 times. Okay. So the field is 0.19. Okay. The current is 2.8 ampere. Okay. The length is 7 times 10 to the power negative 2 meter and times 25 turns. Okay, so I should have 0.93 newtons. Okay, 0.93 newton. So if one, what is the torque that will act on the longer side? Okay, so the torque that will happen will be the force times the distance between it, the two force. Okay, so the force that we calculate is 0.93. Okay, and the distance between these two forces is actually our short side, okay, which is 3.0 times 10 to the power negative 2 meter. So at the end I should have 0.0279 Newton meter. Okay, 279 Newton meter. So part C explains why the force acting on the long side of the coil does not change as the coil rotates, but the torque exerted on the coil varies. So why? Okay, now because the longer sides always stay at 90 degrees to the magnetic field. So as the coil turns, the force is constant, but the perpendicular distance between the forces change as the coil turns, so the torque changes. Okay, so again, torque equal to F times X. Okay, so let's view it from the here. Okay, from the back. Okay, from the back. Okay, now the force whatever happens here, the force will be the same. The only thing that will change is the distance. Okay, again I will put it like this. So this is the original one. Now let's say it will have an angle like this. Okay, now the force that acting on here will be something like this already. Okay, so again you can see the distance between this force has changed, so that I will have a difference of x here. Okay, I have a difference of x here. So what you can say here is the force of is always the same. Okay, but the distance between the forces changes. Wait, sorry, forces, it's not coming up. Changes as the coil turns. Okay, so here this is how it's supposed to be, and when it become like this, it will become like this, so that it will have. So remember, when we calculate the torque, it must be at this to it, so I have an angle between it already. So my torque will become F cross X cos an angle. Okay, so that I make my torque become smaller. So this is what we're trying to explain here.